Section 9. Elements as a standalone blockchain. In the last section, we looked at how to run elements as a sidechain to Bitcoin. In this section, we'll look at how to run elements as a standalone blockchain, with no links or references to Bitcoin at all. In this section, we will do a few things. First, we will initialize a new elements blockchain with a default asset named new asset. Then we'll specify 1 million new asset to be created along with 2 reissuance tokens for it. Then we will claim all the anyone can spend new asset coins. We'll claim all the anyone can spend reissuance tokens for this new asset. And then we'll send the asset and its reissuance token to another node's wallet. Finally, we will reissue more new asset from both nodes. Alright, that's a quick summary of what we want to do. In essence, we just want to use this blockchain that will not be attached to Bitcoin. Alright, in order to initialize an elements network to operate as a standalone blockchain, each node needs to be started with some basic parameters. These parameters are used to tell the node to not try and validate pagans from another blockchain. They also will say the name of the network's default asset and the amount of the default asset and associated reissuance token to create. Alright, we'll start a new chain using these parameters on our 2 connected elements nodes. To be clear, this is the exact same setup we've been using in all previous tutorials, with 2 elements nodes named E1 and E2. Since we've had so many tutorials with this setup, I won't delve into the details of this right now. Alright, now let's start the first elements node with our desired configuration. So what we'll do is we'll type E1 DAE, which is the alias I have in my local shell for the first elements node. And we will pass in a couple of arguments here for configuration. Now, recall, one way to set up an elements node is to pass in configuration arguments into the elements.conf file. So let me just demonstrate what that would look like. So right here for the first elements node, I do have an elements.conf file, and it has all sorts of arguments. But a way to override those arguments is to pass them in through the command line. So I will do that right now with E1 DAE. I'll pass in validate pagan and set that to 0. So now elements will no longer be checking a Bitcoin chain to validate pagans. Next, we will set the default pegged asset name to be called new asset. So this new asset is what we will call this new asset we are creating on this chain. All right. Next, we can configure how many free coins there are initially with the initial free coins. Let's do 1 million of them. So that's 1 with 6 zeros. So 1, 2, 3, 4, 5, 6. Now, one thing to note is that, like Bitcoin, values on elements are denoted in the hundreds of millions. Recall, on Bitcoin, 1 Bitcoin is actually 100 million Satoshis. So 100 million is 8 zeros, and because of that, we're going to have to add 8 more zeros here. So let me count that out with a 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And now let's set the number of initial reissuance tokens we want. And let's set that to 2. And since this is also in the hundreds of millions, we're going to have to add 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So this will launch up a new elements chain. By the way, this elements data directory, elements dir1 that I've shown above, is empty. So this will start a new elements chain with the provided parameters overriding those same values inside the elements.conf file. So we will have a new asset, which is aptly named new asset. We will have 1 million initial free coins that anyone can claim, and we will also have 2 initial reissuance tokens that anyone can claim on this chain. Perfect. It has started, and let's quickly just query that node to confirm that it is indeed running. Perfect. This node is now online. Now let's start the second elements node with the same parameters. So we can do this with E2 DAE, which is the alias I have for my second elements node, and we can just pass in the exact same settings. Perfect. And let's just query that node to confirm that it is running. Fantastic. Now let's quickly check the wallet balances on each node. So if we run E1 CLI get wallet info, we have to create a wallet first on both nodes. So let me quickly do that with E1 CLI create wallet, and I'll pass in an empty name. And I will do the same thing on E2. Perfect. Now let's run E1 CLI get wallet info. Actually, after creating the wallet, we have to rescan the blockchain. Perfect. So once we create the new wallet, we just had to rescan the blockchain quickly in order to make these initial coins claimable. So now we can see that E1 actually notices that it can claim 1 million of this new asset and 2 of this long asset ID, which should correspond to the reissuance token that we created for this asset. Now let's go ahead and run the same command on E2. So let's first rescan the blockchain since we just created that wallet. And next we can run E2 CLI get wallet info. And right away, we also see that E2 identifies these balances, 1 million of new asset and 2 of the reissuance token as its own. And that's, of course, because when we initialized this chain up here, we passed in those values for initial free coins as well as initial reissuance tokens. So these are at first claimable by anyone. To be clear, these assets are created as anyone can spend. All right, let's have E1 claim these assets so that we can remove E2's access to them. We can do this by first getting an address from E1 to send the asset to, which we will do with E1 CLI get new address. Next, what we'll need to do is let me copy this address. And as a matter of fact, let me put this into a variable, which we'll call E1 address, just to make the rest of this easier. Perfect. So now let's send these assets to E1. So we'll do E1 CLI send to address. Let's pass in that E1 address, which we just created, and let's pass in a value of 1 million. That's 6 zeros. And we can just pass in empty strings for these 2 arguments and a true here. If you are curious about what these final few arguments do, please feel free to read the send to address RPC documentation. I will not cover that here. So let's go ahead and send this. Perfect. Now note that here I did not need to specify new asset as the asset to send because this is already the default asset on the chain. Therefore, it's also the default asset used to pay network fees. But as we've covered in previous tutorials, within Elements, you can send multiple asset types to the same address. So we can actually reuse this address that we just generated to receive the default asset and to receive reissuance tokens. So let's go ahead and also make a transaction which sends the 2 reissuance tokens to E1. So we'll run E1 CLI send to address. We'll pass in that address. Actually, for now, let's just send 1 reissuance token. So let's send 1. We'll pass in the following arguments here, which we can just ignore for now. If you want to know what they do, please feel free to read the send to address RPC docs. But the final argument here is actually important. This is the ID of the asset we are sending. So we did not have to specify this last time because the default asset on this chain is new asset here. However, since we want to send some of this reissuance token, let's go ahead and copy this reissuance token asset ID and paste it in here. Perfect. Now we have created this transaction. Now let's go ahead and confirm these 2 transactions. Typically, this would only require 1 block, but since we just generated the chain, we just restarted it, we will have to create 101 blocks for reasons that were touched upon in previous tutorials. Essentially, upon chain creation, you kind of need 101 blocks for things to start working normally. So let's go ahead and run E1 CLI generate 101. Perfect. Now, let's check that E1 is the only holder of the asset and its reissuance token since it just claimed it. So let's run E1 CLI get wallet info. And we can see here that indeed E1 CLI still shows it has 1 million of new asset and 2 of this other asset, which is the reissuance token. And let's go ahead and run the same command on E2. And we can see that in fact it has 0 of this new asset and the reissuance token does not show up. Perfect. So E1 has now claimed all of these initially issued assets. Now let's go ahead and send some of this new asset to E2. So we can do this by running E2 CLI get new address. And this is the address which we will be sending to. And once again, actually, let me just assign this to a variable to make the proceeding section easier. Perfect. Now let's send some of new asset from E1 to E2 with the same send to address RPC. So previously, we sent the tokens to E1 using E1 to claim them. And now we will send them from E1 to E2. So here I'll pass in this E2 address we just created with using this E2 address variable. Next, I'll specify in amounts, which let's for now send 500 of this new asset. Perfect. And we can provide 2 empty strings here and false. Perfect. Now, let's go ahead and execute this. Note that we did not have to specify that we're sending that new asset type. Since this is the default asset on the chain, that was automatically assumed. So we have this transaction, and before confirming it, let's go ahead and send some of this reissuance token to E2. So we have 2 of the reissuance token on E2. On E1, let's go ahead and send 1 of those to E2. So we can do send to address. E2 address will provide 1 reissuance token. We can provide false, false, 1, unset, false, and then we can pass in this reissuance token ID. Perfect. Let's just press enter now. And that also got executed in this transaction. Perfect. Now let's go ahead and confirm this transaction with E1 CLI, both of these transactions actually. Generate, and we will type 1. Perfect. Now let's check that the wallets have updated accordingly. We'll run E1 CLI get wallet info. And right now we can see that instead of 1 million of this new asset on E1, we have 1 million minus 500, which would be 999,500. We actually have a little bit less than that because a little bit was deducted to pay for the fee. Since the default asset here, new asset, is used as the fee asset on the chain. We can also see that rather than 2 of this reissuance token, we now only have 1 on E1. Now let's go ahead and check E2's get wallet info. And on E2 right away, we can see that it now has received this 500 of the new asset. And it has also received the 1 reissuance token. Perfect. So we created this new asset on this new chain, not connected to Bitcoin. We claimed all of our initial free coins on E1, and now we've sent some of those along with a reissuance token to E2. Now, let's reissue some of this default asset from E1. Note that this ability of reissuing the default asset is enabled by that initial reissuance token startup parameter we passed in earlier. If that parameter is omitted, or if it's set to 0, this will result in a default asset that cannot be reissued at a later date. But in this case, we specified it so we can go ahead and reissue it. So we can do E1 CLI reissue asset, new asset. So here we pass in the name of the asset we're reissuing. And let's reissue 100. Perfect. Note that we were able to use the label new asset instead of having to provide the hex ID value like we have to do for the reissuance token, because an Elements chain always labels its default asset. All right, let's go ahead and confirm this reissuance. And now let's check that it worked with get wallet info. Perfect. Right here we can see that we now have the previous value, which was 999,500, plus 100. Of course, this is 599 and not 600 because some was subtracted for fees earlier, and it was also subtracted for fees now. So these numbers are a bit off because of the small amounts we are paying for fees. Now let's go ahead and prove that E2, since it holds some of the new asset reissuance tokens, can also reissue this default asset. Since recall, we sent a bit of it to E2 just now. So let's do E2 CLI reissue asset. So this is the same command. You know what? Let me just scroll up in my shell history and re-execute the same command, but with E2 CLI instead of E1 CLI. Perfect. Let me run that. And now let's go ahead and confirm this transaction with generate. Now let's go and check the wallet information. And here we can see that E2 has 500 plus 100, which we just issued. Of course, this is also a bit less than 600 because of the small amount that was subtracted for a fee. But we can see that using this reissuance token, both nodes were able to issue some of this default asset. All right, let's recap. In this section, we have set up Elements as a standalone blockchain and checked that basic functionality works as we would expect. We use startup parameters to initialize a new Elements blockchain with the default asset named new asset. Then we specified the amount of the default asset to create on-chain initialization. We created some reissuance token for the default asset, and we reissued more of the default asset from both nodes using these tokens. On our standalone blockchain Elements network, all other transactional operations will operate in the same way as the examples covered in the main section of the course, but they will use new asset, which is what we named this, the default asset, instead of Bitcoin as the default and as the fee asset. Thank you for listening. I'll see you next time.